Now, at this point in time, I'd like to bring in Hidenori Abe, Corporate Officer, Resonac Holdings Corporation, to give a JOINT3 presentation. Now, Mr. Abe, please. Well, of course, I'm in charge of semiconductor development at Resonac. I am Abe, as introduced, and I am very pleased with this opportunity to be able to talk about establishment of JOINT3. Of course, as a member of Resonac, our activities on the forefront of what we will be talking about has been my a long-term effort. And of course, I was talking about with some of the management members what it is that we need to pursue. We thought about this panel level Interposer to be the next hot area where a lot of demand will take place. Now, of course, I had dialogue with more than 130 companies to this date, and we were able to bring you some fruits of previous efforts. Now, let me talk about this slide first. When it comes to evolution of AI and semiconductors, AI advancement is so astonishing, and ChatGPT has changed the world. And of course, going forward, there's robotics and autonomous vehicle, driving coming forward after data center. Of course, AI itself needs to evolve over time, and for that, of course, semiconductor evolution is necessary. So, how is evolution of semiconductors achieved? Let me talk about the front-end process and back-end process, as well as and of course, when it comes to front-end process, people feel that there is not much upper room when it comes to technology advancement. Of course, that brings our attention to the back-end process for future technological jumps. And of course, conventionally, it's a basic chip and it's just one chip. But over time, the complexity of semiconductor structure had evolved over time, and now highly integrated chips, not just one, but multiple such chips are now in need. Now, when it comes to our conventional semiconductor packaging and advanced packaging, what are the differences? Now, one of the big differences is that in the past, there has been what's called the motherboard, and on that motherboard, memory chips have been placed, and then there is a processor placed board as well. So, it's a memory and processor through the motherboard foundation have exchanged information, data. But for us to fully support the technology going forward as it is needed, we need to have a fast, high-density connection and high-speed transmission, and then we need to have what's called HBM that's already in use with a high stacking of memories, and then a combination of HBM and GPU via Interposer. That technology in itself has started to be in use. This is shown in the slide with a red arrow. Of course, that condenses this power signal that transports the data. And of course, it is the chiplet integration, as you know. Now, let me now talk about this roadmap in terms of technology trend, increasing number of chips, and enlargement of Interposer. In the past, the material was silicon-based, but now it's RDL, or what we call chip embedded or die embedded Interposer, and this is organic origin. Now, in addition to that, in order for the calculation process to be accelerated, the logic chips and the memory capacity had been embodied in the same package more so. So the package size has gotten bigger. Now from 47 to 60, 73 times 108, large size indeed is going to be in need. Now, this large interposer, how are we going to manufacture such interposers? Now, what used to be the round type, as you know, the size is 300 millimeter, but if we were to cut out 73 times 108 size interposer, we can make 4 interposers out of this full round type silicon interposer base. So how are we going to make progress? Well, square shape and large square shape indeed had been under discussion as a solution to this problem. Of course, there are 2 types there, RDL interposer. So instead of using silicon, there is going to be the type of material that is specific to this with a copper plating. And of course, die-embedded interposer is another type, and in that case, what's called the encapsulation material is used, as opposed to in the RDI, photosensitive insulation material is used. But this large size chip creation is indeed quite a difficult challenge. It requires further R&D. Of course, there is demand that we recognize. Now, what I can explain now is this keyword, this glass interposer or glass core substrate. You can see at the down bottom. In the final product, there is a glass, physically, and R&D is making progress towards that direction. But what we are trying is what you see up top, panel level organic interposer. But in the middle process, glass is used. However, in the final product, the glass is not present. So that's the difference. It's a difference between the top technology and then the bottom technology that I wanted to highlight. Now, when it comes to a comparison of panel level organic interposer and a conventional FO-PLP, what are the differences? Well, that's summarized here. And of course, FO-PLP technology had existed from a long time ago. It used to be WLP wafer level technology. The use is mobile AP, telecommunications, whatnot. This is not so complex. However, that's after to shift to panel level packaging. There's a roadmap created in the past in order to reduce the cost of production. However, there's a question as to, well, is that capex needed for that, rational enough for the benefit? So it hasn't really been advanced. Currently, instead, what we are looking at is panel level organic interposer, AI server, it's AI, it's large size, and very difficult technology is required when it comes to interposer creation. Of course, there are technological issues, hurdles, bars to be overcome. So we need to advance technology to do so. Now, when it comes to key challenges in large panel manufacturing, these are the challenges. Now, what used to be wafer level 300 millimeter, but now the large size of 550 millimeter need to be handled, and that affects different processes. And of course, this is a big size, and there's going to be the accuracy, issue involved here. And then in case of placing like liquid material, wafer level well, it was easy. It could be layered evenly, but when it comes to this large size or page, this even placing of the material became more difficult. So there are these types of issues that need to be overcome. That became the idea of JOINT3.
In other words, the voice that this kind of the problem arising, we talked to many different experts, and also that the 1 microns, the line space, this is a very difficult technology. For such difficult technologies, R&D is required. Material manufacturers have a very good technology to each other, but they would like to have a cooperation, but the cooperation has not advanced very much. In other words, support the evolutions. Of course, panel level evolution is required. That is why this kind of evaluation should be done more quickly. And also that the evaluation that the platform should be commonly established. So this is a very heavy investment for one company to bear from the perspective of the material manufacturer and equipment manufacturer. That's why we decided to organize a consortium. So JOINT3 is a new initiatives. Resonac is going to serve as the main player here. So we are now inviting the material manufacturers and equipment manufacturers. Total is 26 billion yen. This is the total project cost. This is a 5-year project that we receive the investment from the companies, and also that the large-scale panels by using the prototype line, such as 515 by 510, that the to develop the materials and equipment for organic interposer. So materials equipment manufacturer will co-create by utilization of the common test vehicles. So that I hope the equipment manufacturer will use JOINT3 as a training ground to define technologies related to the panel level organic interposers. Then, what is the difference between JOINT2 and JOINT3? Let me explain. When it comes to JOINT2, this is the packages for the elements. Funded projects, we received the fund from Japanese office, Japanese government. We collaborated with 14 Japanese companies. That is why we try to achieve the defined development target. We are still working, so this project is going to be finished in 2026. JOINT3, this is a large-scale panel-level organic interposer plus 2 XD package full integration. These will be included in R&D. Furthermore, without using any other subsidy, we are just focusing this that project only by the private companies, global 27 companies, and this is consortium by the private companies. That is why we are flexible to change our target in accordance with the trend in the market, and also we have a very good environment which accelerates open innovation. So we are going to create an uplink. So in trying to gain more business. So that because of the NIDO and the JOINT2 we have already established the foundations. So advanced panel the level interposer center, I'd like to explain to you about the uplink. 510 and 515 millimeter, we have created a full panel a prototype line. So we are going to create 8 to 12 the theoretical size big scale interposer. Packaging is going to be done, carried out by the packaging solutions up until the evaluation for the reliability. So this is JOINT3 participating companies. So from Singapore, Germany, and USA. Not only Japan, but we have a collaboration from global companies. So the difference between JOINT2 and JOINT3, so far is we have many companies who are engaged in the back end, but we have had more companies who are engaged in the front end, and also design and measurement. Such companies are also involved. So lastly, about the logo for JOINT3, I'd like to just give you the message behind this JOINT3 logo. This is the circle. So envision a circle of co-creation where people, technology, and passion connect and propagate. That's why we just put this red circle, and this red dot symbolizes just above the circle. We have the global competition platform from Japan. So as Japanese company, of course, that we would like to keeps and maintain and also to facilitate the semiconductor industry in Japan. However, Japanese company alone can't make an inroad into the global stage. That is why we need to have a good competition with the global companies. Thank you very much for your kind attention.